this video, we'll build a project that will teach you how to utilize test-driven development, or TDD, to write highly efficient code, and in turn, that will make you very employable as a programmer. For the job seekers out there, I've pulled up all the jobs in my state of Michigan that require either knowledge of test-driven development or unit testing. And you can see by the results here that there are about 800 jobs that require knowledge of unit testing and about over 400 that require knowledge of TDD. So that's over 1,000 jobs that require knowledge of either, and in this video I'll teach you to understand both. Now, TDD works great if you're coding from scratch, like you're creating a new project, but sometimes you'll be asked to contribute to or enhance code that's already part of an existing project. Don't worry though, we'll be going over that use case later in the video, but for now let's just quickly cover the basics of test-driven development. So test-driven development means that we use tests to drive the writing of our code, and I have this handy diagram here that's going to illustrate the workflow that we describe as red-green refactor. Now this is a cycle that can be used for every test, and red means that we'll be writing tests for business logic that we expect to fail at first. Green is the stage where we'll write minimal code so that our tests pass, and finally on blue we refactor our code and test to make them more efficient. And now that you have an understanding of the workflow of test-driven development, let's build a project that's going to allow us to learn the principles of TDD in a practical manner. Let's imagine that we are given a task to write some code that will check if a book's ISBN number is valid. Now I'm going to write this down so we know. Now the ISBN number is a number that's on every single book that's printed and is going to be a unique identifier for the books. If you're unfamiliar with ISBN numbers, basically it involves simple math to do a calculation, and I'll just look it up here so we know the rules, how to verify an ISBN number. Basically what we're going to do is take the ISBN number, there's going to be a 10-digit or a 13-digit one. Now for the 10-digit numbers, all we need to do is take the number and then we have a position in reverse numerical order. Then we just multiply each of these together and sum up the product of all of that. So what it looks like would be 0 times 10, 0 times 10 plus 7 times 9, and so on down the line, and then we get a sum. And if the sum is not divisible by 11, which means there will be a decimal point or anything that's not a whole number, then it's not valid. But if it is able to be divided by 11, as we see right here, the sum is 17, then this is a valid number. So it's very simple math, and we're going to write a program that's going to allow us to validate a number. Let's now create our new project that is going to help us accomplish this task. So we will say new project. We can go ahead and skip this, and we will call our new project ISBN Validator. Now I'm going to be using IntelliJ to set this project up. If you are in Eclipse or VS Code, that's totally fine. The only thing that's going to vary is the fact that we need to import JUnit 5. JUnit 5 is easily imported in Eclipse and VS Code. I think it's done automatically. For the IntelliJ users out there, I'll demonstrate really quick how to import JUnit 5. For now, let's go ahead and create our first package, and this package will house our class, and the package will be called ISBN Tools. Inside of the ISBN Tools package, we will create a new Java class and call this Validate ISBN. So our first class is set up now, and we can go ahead and start creating our test, because remember, all of our code is driven by our test. We won't write anything in here until we have first making a test. So to kind of show our IDE where our tests are located, we're going to create a directory. And to do that, we're going to go up to the project level up here in the top left, select new, and say directory. This directory will be called ISBN Validator Tests. And this is going to span the whole scope of our project. It's essentially going to mirror our source folder, and to mark it as a test directory, we are going to right-click it and say mark directory as test sources root. So now our IDE knows that this is where our tests are housed. Let's create our first package here, and we will call this ISBN tools. Again, we are going to somewhat mirror our source folder, and we'll create our first test inside of this package by right-clicking and new Java class, and we will call this validate ISBN test. So this class will test all the functionality of our validate ISBN source class. So let's make our first test and make sure that everything is working fine. We can write the annotation at test and finish this up with a signature. So now we need to get rid of this error, and to do that we can hit Alt Enter or select this little icon here, and we will say add JUnit 5 to class path. And this is the library that we'll be adding right here. We're using JUnit 5 again, and you can go ahead and hit OK. Now if you don't have the option to import JUnit that way, and also if you did have the option to do, we will also have to say import class here. But if you don't have that option, what you can do is go up to File, Project Structure, and we'll go down to Libraries, select the Addition button, and say From Maven. Now the directory or library that we're looking for here is the org JUnit Jupyter 5.4.2. You can also go ahead and type in keywords like JUnit and search for any version that you would like to add. We will be using JUnit 5 though, so go ahead and hit OK, and then we can apply this. So we're all set here, and a very integral part of test-driven development is to make sure that the tests fail first. So to do that, we can call a JUnit method named fail, and this is going to ensure that our tests fail every time. Now we can run the test, and to do that we can either select this icon here to run one test, or we can run the whole class. For now we'll just run the entire class, and we see that our test failed. Now this might feel wrong or weird, but I'll show you why it's important to make the test fail at first. But before I can do that, we need to have a working test, so we'll move on for now. But let us also try to comment out fail here and just make sure that this test is passing when we comment it out. And we see that it passed. So now we can start creating the test for our task, which, as we know, is to validate a 10 or 13 digit ISBN number. We can head over to Amazon and get a valid ISBN number here. So this is cracking the coding interview, and if we scroll down we can see that there is a 10 digit as well as a 13 digit ISBN number here. For now we'll only be concerned with the 10 digit ISBN number. Given the fact that we know this is a valid 10 digit ISBN number, I'd like to write a first test that says if we pass in a valid ISBN number to a method, then we expect that method to tell us that this is a valid number. So let's think about why this is a good first use case. A good way to approach TDD is to test the obvious use cases first and then move to the edge cases. And when we write these tests, we only want to think about outcomes, not the business logic, architecture, or even the design of the code. Now that we determined our first use case to test, let's move into the red stage of TDD for this test. And we know that is writing a test that will fail. And we will just copy this here and paste, and we can change this method signature to say check a valid ISBN number. Again, we're going to call this fail method, and I'll get to its importance later, but let's run this and check if it fails. And we see that this test fails, and if we take a look down in the bottom left, we can see that we have one test passed and one failed. The one that's passing will be marked with the check mark here, that is our example test, and the failing method is our check a valid ISBN number. The next thing to do is create an instance of our ISBN validator class, so let's go ahead and create that. Okay, that looks good, and now we're going to need to call a method inside of our class that is going to take in a ISBN number, a 10-digit ISBN number, and return that it's valid. So let's now create the method call for that. And you can see that we still need to create it, but let us pass in a valid ISBN number, which we can find right here. Now it would make sense that this will return true, so we can go ahead and save this in a Boolean variable. It's important to note that right here, we're currently passing in the number as an integer. Now, I don't know right now if that's the right thing to do, but this is all part of test-driven development. We could be using a string, but right now I don't care. All I care about is that if I pass this value, I get true returned. Now, we could refactor this in the refactor stage, but for now, we'll see. It seems like an integer will do. And remember that our tests are going to be driving every aspect of our code, so we have to keep on going until we have a test that determines if this argument should actually be a string. Let's complete this test now by making an assertion. And since we're expecting this check ISBN to return true, we can use the JUnit method assert true, which will tell us if this value stored in result is true or not. If it's false, then this test will fail. If it's true, then we'll get a passing test. Now there's all kinds of different asserts that you can make, such as comparing two objects, checking if a string is an array. You can assert false and do all kinds of things that we'll be going over later, but for now we're just going to leave this as assert true. Now to get our code to compile, we're going to have to create this check ISBN method inside of validate ISBN. So here I will create the method signature. So this is our new check ISBN method, but we see that back in our test class that the compiler doesn't like the integer here, it's too large. Let's go ahead and delete a leading 0 and run this test. And we see that it compiles, but it fails, and that's due to the result variable being false. Now we've completed the red part of the red-green refactor cycle, and let's move on to the green part and write some code that's going to make the test pass. Before we do that, I think it's important to say that in the green stage, we write the minimal amount of code to get the test to pass, and we're not interested in building the full functionality. So how could we do that? Well, we could come over here and we could change our ISBN method to return true. Now, this will feel like the wrong thing to do, but it'll make our test pass, so it's the right thing to do, and we'll be changing it very soon. Let's run our test and we will see if it passes. And we see that it does. And now we've completed the green stage in our 3-stage cycle, and we can move on to the refactor stage. But there isn't much to tidy up other than we could change this I to say ISBN number. Then we can rerun the test just to prove that we didn't break anything and that it works. And it's working just fine. So don't worry that this might seem like a slow process, because that's just for now. It's going to speed up as we move along. So let's put in a second test and go through the cycle again, except now we'll test if an ISBN number is not valid. So to do that, all we need to do is copy this method here, or this test, and we can paste it right down here. We will change it to say check an invalid ISBN number. And through the nature of ISBN numbers, we know that if you take a valid ISBN number and you change one of the digits, then it's going to become invalid. So we'll just change this last digit here to say 5. And this is now an invalid number. Therefore, we're expecting the value of result to be false. So we can just use the assert false JUnit method right here. And now we can go ahead and run this test. And we can see down here that the test passes. However, this is not actually a good thing. And now is where I can talk about why we should always start with a failing test at first. So I purposely wrote the wrong code here to demonstrate importance. You may have noticed that I forgot the test annotation that belongs on top of the test method. So actually this whole second test, or third test, sorry, is not even running. And we can see down in our window that only 2 of our tests have ran. So this is a common mistake, and if you're churning out many tests and make this mistake, you'll carry on through your entire program with an error in your code. What I should have done is put assert false, the fail method before the assert false, and in that way I know that I am expecting a red bar to appear in this test, and if it doesn't appear, then something is seriously wrong. And of course we don't have a red bar here, so I know that something went wrong. We can go ahead and take away fail, and we know that we forgot the test annotation, so let's put that in. And we're set to go. So now we can move on to the green stage of our code, which by now you know is writing the minimal amount of code that will get this test to pass. So one thing I could do here is actually take this value here and create an if statement or some logic that will allow both tests to pass. Now we know that this is not good code, but for the purpose of test-driven development, if we're not taking any shortcuts, this is the right thing to do. And now if we go back and run our test, we see that all three tests are now passing. So the next step is we can add more tests to achieve proper functionality for our check ISBN method here. We could start by adding a test using a second ISBN number. So let's head over to Amazon and grab another ISBN number. And here we found basically the Bible of algorithms. And we see a nice 10-digit ISBN number right here, which actually looks, or it appears to be more than 10 digits. So let us go and grab another one. And here's a good 10-digit ISBN number that we can use. So we'll give that a copy. And actually, before we paste this ISBN number into use, we're faced with a decision. And that decision is we can choose to create a new test method for our new ISBN number, or we can add it to this first test method. So an important aspect of TDD is that each test is on one single identifiable piece of logic. And normally you'd have one assert per test method, but there are times when you're going to need more than one. For example, when you expect a method to set 3 or 4 variables in a class, you can write a valid test that asserts each of the variables. Another example is when you want to test multiple values that are just different examples of the same thing, which is actually what we're doing right now. So we have two valid ISBN numbers and expect them both to return true. So let's write up some code that's going to change our test here. So this is the new code here, and you can see we just reassigned the result variable here and made another assertion. Now we need to copy in the other number. And we'll get rid of the leading zero, and we're good to go. So now let's run this. And we see that our test fails here. Looking down, we can see that the second value, we expected a true, but it was false. So now we can go ahead and move on to the green stage where we're going to write the minimal amount of code that will validate any ISBN number. And we're going to jump right to that case because as you see, we don't want to keep adding conditions for each new ISBN number. We don't want to keep adding if conditions like that. That would just be poor code. So now I realize that we need to check if the data entered is 10 digits long because that's the first step in order to validate an ISBN number. Now we have to decide between making our parameter a long value or a string. For now, we'll make it a string because we know that an integer can't be 10 digits. So let's go over to our class and change this parameter here to string, and then we can go back and change these values here to represent a string. And also don't forget to add the leading zeros here at the beginning. This looks good here, and now back to our check ISBN method. We'll have a go at this together, but again, we're going to write logic that says given any string, check if it's a valid ISBN number by performing the math. We're currently not worried about the length of the string, but we know to be a valid ISBN number, it has to be at least 10 digits, and an integer cannot be 10 digits. Just as a reminder, a valid ISBN takes each digit and multiplies it by its position starting at the first digit and descending down the line. I'm going to make a mistake here in this code that we'll discover later in order to make a point about how TDD works. If you spot it, don't worry, I'm going to pretend like I haven't noticed. But anyways, let us get to writing this logic. So here I started with a variable called total, and total is going to keep track of all the addition and multiplication that we perform with the digits in their position. Then I made a for loop to cycle through all the digits, and I only used 10 here because I'm not worried about the string being the wrong number of characters for now. Then for each of the characters in the string, I'm going to multiply it by 10 minus I and add that value to the total. The only thing left to do is check that if the total is a whole number, then we are going to return true. And to do that, I use the modulus operator. Else we are returning false. Now let's run this and see if our test will pass or fail. And we see that every test is passing here, so everything's looking good. Now let's deal with the other things that we know about ISBN numbers, starting with the fact that they always must be 10 digits long. So let's add this test, and again we'll create our test with a fail method to start. So this is our new method here, 9-digit is not allowed, and we have it failing at first. We can run this and see if it passes. Also, it is important to note that it is a good practice to make the method names very descriptive, and in that way you can know which test is passing and which is failing right away. And it looks good, 9 digits not allowed is failing. So now we can write some code to call the validator, and this time we're going to pass in a 9-digit number. So let's go ahead and copy this here. We can paste it in and get rid of the 0 here, and we know this is 9 digits. We'll also assert that the result will be false. So let's go ahead and run this, then move on once we know it is failing. And we can see down here that our 9-digit is not allowed method is failing. So before we move into the code of the green stage, we're faced with a design choice. I think that if the ISBN is wrong, then our code should throw an exception. And in this case, Java's number format exception is going to work here. So let's expect that if check ISBN is called with this number or any 9-digit number, then an exception will be thrown. If it isn't thrown, then the test will fail, and if an exception is thrown, then the test will pass. So in JUnit 5, we can write the following. So again, we can run this and see that it is going to fail. And we see that the test does fail. So before I go in here and write the code to make the test pass, I'll ask you to pause the video yourself and try it out. And then you can come back and look at my solution. So I hope you got something similar to this, and it doesn't appear that there's any refactoring that we need to do at this stage. So let's just go right ahead and run this and check if our test is passing. And it is passing just fine. Now I think that the next thing that we should probably do is check if the value passed in is not all numbers. So if we pass in, say, a string that says hello world, we want to throw a number format exception. I'll ask you to pause the video again right now and write a test to check that the string hello world throws a number format exception. You might also notice that hello world is conveniently a 10-digit string, but don't worry about that for now. Remember, we're learning about business requirements bit by bit, so right now we believe the business requirement is that every character is a number. So go ahead and pause the screen now and write the test to check that if we pass in hello world, then we'll get a number format exception thrown. And I will start writing that right now. So you can see that our new test is very similar to the 9-digit not allowed test, although we have hello world. So let's run this and make sure that it fails really quickly. Alright, so our test is failing just as expected. Now before we move on to the green stage, pause the screen again and try to write the code on your own in order to make this method, or this test, pass. So hopefully you've gotten something similar to this line of code, and now let's check and see if this line of code will allow our test to pass. So we can see that this test does in fact pass in the bottom left. This is great, but now I think we need to deal with the fact that ISBN numbers can in fact end in an X. So let's get an ISBN number that is valid and ends in an X. I already have this loaded on Amazon here. The Last of the Mohicans has an ISBN number that does in fact end in an X, but it's still valid. So we'll use that ISBN number, and let's create our next test here. and make sure that it's going to fail at first. And we'll check if it fails very quickly. So we see our method does fail, and actually to make sure that a number passed in ending in an X will return true, we can do something similar to the methods up here above, and we'll just go ahead and copy this here. We'll paste it right into our method. We can go ahead and get rid of our message, and then we will copy and paste this valid number and put it into our testing method. Now let's run the test and see the result of that. So you see that we've ran the test, it failed with the message ISBN can only contain numbers. So instead of pausing the video and trying to implement the test, we're going to do it together and you'll see why in a moment. If we want to make this test pass, I think that while we're in the for loop over here, cycling through all our digits, inside of this if condition that checks if the character is not a digit, we can make another condition that says given the character is not a digit, then if the character is X and I is equal to 9, that means it's the last character. So basically, if the last character is X, then we do nothing, else we throw a number format exception. So let me write this out and we will see how it looks in a sec. So this is our new logic that basically says if the character we come across is not a digit and I is equal to 9, and that character is equal to X, then we'll just go ahead and skip right through here, else we will throw an exception, a number format exception. So let's run this test now and see if it passes. And we actually see that our test fails, but it is not due to a number format exception, it's due to an assertion error, which basically means that we have expected true, but we received false. That means our result variable is false here when this should have returned true, a valid number. Now, essentially, this means our code hasn't calculated it's a valid ISBN. Now, how can we change that? Well, if we're to read the Wikipedia page, then we would see that the letter X actually takes on the value of 10. So when we're adding to the total, we need to check if the value is X, and if it is, then we'll add the value as 10. Because we're multiplying all of these numbers down the line. 0 times 10, 1 times 9, 2 times 8. So this would be 10 times 1 here, and as we know 10 times 1 is 10, so all we have to do is add 10 to the total. So let's go and do that right now inside of our if statement. So here's our new logic, and we can also go ahead and put this total calculation inside of an else statement. Now let's go ahead and run this and see if that has changed our problem. Well, we see that nothing has changed and we still have a red bar. So let's try to understand what's happening here. And I'll confess up front, I knew this would happen. I said earlier we would discover a mistake, and now is the time to go over it. The point I want to make is when you're solving a problem, don't create another one. So if we set a breakpoint here in our test method and we run this code, now we can go ahead and step into this, and we will be running the check ISBN method for this ISBN number right here. Now, of course, we know that the length is 10, so we're going to step right over this, and we're initializing total here, going into our loop, and this should skip right over the if condition. It does, and we go to else. So what should be happening here is that we are multiplying 0 times 10, because 10 minus I is 10. Now we see something strange, that our total has went to 480. Well, the reason for this is because our ISBN number .char at I is returning the number 48. And this is due to the fact that 48 is the ASCII value for the number 0. So to fix that, we can write this following code. So let's now quit this debugging as we have identified our problem, And basically all we're doing here is we're getting the numeric value of the number instead of the ASCII value. So let us rerun this test and let's see if it works. And we see that all of our tests are passing. So this is just a quick lesson in test-driven development and a few of the principles that we need to follow. I'll be making another video on test-driven development in Java where we'll continue to add additional cases on here, much more complex than what we have done. So that'll be it for this, and we will see you in the next video.